Substitution reaction which follow first order kinetics is SN1 reaction, which is substitution nucleophilic first order. The reaction rate was found to be independent of the concentration of the nucleophilic reagent. Rate is found to be proportional to the concentration of the alkyl halide substrate only. This suggested that SN1 reaction mechanism is of two steps. First step is formation of carbocation where the leaving group departs. This is the slow rate determining step. The second step is attack of nucleophile, which is fast. The energy profile diagram of SN1 is like this. Now, as the first step is formation of carbocation, therefore tertiary alkyl halides are favored in SN1 because tertiary carbocation is most stable. Watch this animation. First, the leaving group departs. The carbocation formed is planar. The nucleophile now may attack from either side. If the leaving group is attached to a chiral carbon and the alkyl halide substrate be an R isomer as this one, the leaving group departs. The carbocation formed is planar. The nucleophile now may attack from either side. Then we get the product which will have 50% of the R isomer and 50% of the S isomer and is called a racemic mixture. Thus, SN1 leads to racemization. Sometimes SN1 reaction proceeds through another step after the first step, and this step is called carbocation rearrangement. This happens if the carbocation formed in the first step is not a tertiary carbocation and the carbon attached to the positively charged carbon is either a tertiary or a quaternary carbon atom having a methyl group. This carbon is sp3 hybridized and is free to rotate. At a suitable conformation, when the hydrogen is in line with empty p orbital, the hydrogen along with the bonded electrons shift like this. Which is called hydride shift, and due to this hydride shift a more stable carbocation is formed. In this case there is a methyl shift and a more stable tertiary carbocation is formed. There are more complex rearrangements in cycloalkanes. A typical example is like this. This is the substrate. The leaving group departs forming a secondary carbocation where the positive charge is on this carbon. Now let's rotate the camera position for a clearer view of the mechanism of rearrangement. The rearrangement may happen by taking electrons from any of these three bonds. If it takes electrons from any of these two bonds, then there is a methyl shift and the carbocation formed is a tertiary carbocation with positive charge on this carbon. If the electrons are taken from this bond, then there is a ring contraction. The rearrangement will give a tertiary carbocation having positive charge on this carbon outside the ring. Summary. We can judge a nucleophilic substitution reaction as to what mechanism it will follow. Will it follow SN2 or SN1? The following factors are to be considered. Substrate. Primary alkyl halides favor SN2 and tertiary alkyl halides favor SN1. Secondary alkyl halides may follow both or any one depending on other factors. Nucleophile. Strong nucleophile favor SN2, whereas weak nucleophile favor SN1. Solvent. Polar aprotic solvents favor SN2 because they increase nucleophilicity of the nucleophile, while polar protic solvents favor SN1 because they decrease nucleophilicity of a nucleophile.